for your chiropractor bills after your neck goes out. Okay, so here we are, down the front. Requirements engineering. So this is a topic that you're probably not all that familiar with. You're probably wondering what is it? What does it involve? What are the steps? But all will be revealed over these next 2 hours. We're going to go through piece by piece, starting from the beginning, assuming you've never heard of what a requirement is. And by the time you leave this lecture, you'll know something about requirements engineering. Not enough to be experts, but that's okay, because it'll be covered in the next week's lecture as well, and in this unit and in the other unit. And there's about 4 more units where we cover this requirements engineering. As I'm just taking it with a straight face, it's good.
What are we called?
So, sorry, what?
Self-harm 101, yeah.
What did you say?
While you're recording, probably shouldn't say it.
Yeah. And at this point in the class, I should maybe point you guys out if you are experiencing difficulties. ECU offers a complimentary counseling service. It's completely confidential and completely free. So if you're getting mental anguish about getting presented the same things in different units 10 different times, just make an appointment and they'll talk you through it. I don't know, do they do a good job? Like I said, completely confidential. Alright, so the goals of this session to describe different techniques to elicit requirements, to determine different types of requirements, to see how an existing requirement specification can be critiqued and refined, and also to learn the basics of a requirements analysis technique. I'm just trying to force you to go to sleep. It's too early in the class.
No, I had a cup of coffee this morning. So.
Are you a cheater?
Yeah, you're not going to be.
That's okay. Well, who else can I pick on today? I had you all lined up.
Well, you could pick on anyone, but the question is, who will you be picking on today?
Oh, hey. Yeah, there's a bit of fluff on it. Do you want me to slam the door? No, nothing. And we start with some references. So, I'm sure you guys have been through these lectures early on, and you've read through these. Now, using Griswold's template to summarize them, of course. Have you gone through those?
No.
What about these ones?
No.
Don't go through those. So we're going to talk about the most important parts, right? The topic requirements engineering. An important thing is, what is it? And if you get asked in the exam, okay, how would you characterize requirements engineering from, what actually is the process? I mean, we're going to talk about all kinds of things like doing interviews and checklists, but what is it? This tells you what it is. It's requirements analysis, that's what it says. But basically it's the process of transforming your problem definition into your requirement specification. That's what it is. That's requirements engineering. Where you go from a definition that maybe isn't in a problem definition document. Maybe the problem definition exists in the minds of the existing users. It exists on all different kinds of documents. And you do your requirements engineering workflow, and at the end you result in a formal document, and there's the IEEE whatever specs up on Blackboard, you know, to give you a guide of what that looks like. You're going to be producing one for assignment 2, I'm pretty sure. But it results in a formal, legally binding document that the client signs off, that you sign off, that this is what I'm going to deliver. Right? And once the client signs off, that's good. You can be assured that if you implement what's in the specs, you're going to satisfy the problems, you know, because the client signed off on it. So it's a very, very important thing. Right? Don't worry about that. So there's problems associated with it, right? And kind of hinted at that when I said, well, it's the problem definition isn't nicely packaged up for you in one concrete document that you read and you say, okay, this is exactly the problem I need to tackle, right? How could you work out what the problem is? I mean, you could ask your clients, but the thing is they wouldn't be able to tell you exactly, right? And we talked about that before. Right? And there's many problems working out actually what is the problem. No? You talk to different people representing the clients and they'll give you a different version of it. You know, some of it might be politically driven, some of it might be due to misunderstandings. You know, if you're tasked with proposing a system to solve this problem faced by these people and you're talking to their manager, maybe even the manager doesn't understand properly what the problem is. Right? So humans basically are very limited creatures. Right? I've grown accustomed to them. Sometimes I'm even quite fond of them, no, through teaching them. But you know, their minuscule brains just don't cut it when it comes to requirements analysis. No? Right? It's there for some random reason. You've seen that, right? The requirements process. Don't worry about it. Okay, so here we go. Right? So do you want me to go back and take you through the software development life cycle again? No, right. See, I knew that. So basically, somehow you have to come out with what the system specifications are. Right? This is a key slide, right? So these are the different ways to elicit in requirements. Asking the client what they want, what they expect. What do you expect? What do you want from this unit?
Not quite sure. A pass.
Just a pass.
Yeah.
Well, that's good, and I'm going to make you work for that pass then.
You'll be very happy.
So, if you get 90% in the assignment and the exam, I might consider giving you that pass.
Yeah.
That's good. And that's actually a very important baseline, you know, because from a software developer's point of view, well, you don't want to under-deliver and over-promise. No, you want to under-promise and over-deliver. But it's very important to set kind of a baseline of this is what the client expects. And you know, I mean, you're doing this job to get paid, to get as much money as you can from this project and go to the next project. So once you work out the baseline, your interest is to deliver at that baseline. You don't want to deliver under because that hurts you. You don't want to deliver over because you're giving something for nothing, where you could be putting that effort into other places. Right? It's actually a very important concept. I mean, if you take that as an analogy, you know, let's say you have a mining company, Rio Tinto, and they have an iron ore mine. You guys are familiar with this concept. They dig stuff out and it's called iron ore. So it's not pure iron, it's not like a solid lump under there. It's basically this rock and it has some concentration of iron in it. And the contract they sign with their client, whoever's buying this iron ore, is that the client buys iron ore and they want a certain grade of iron ore, which basically means a certain percentage of that is actual iron. Right? So they take the money. It doesn't cost them any extra to dig out the high grade versus low grade, right? No, you just dig it up. It's the same digger doing the digging. It doesn't cost any more or less. But if the contract is, okay, I want iron ore, let's say, I don't know what realistic percentages are, maybe 20% iron content. Let's say I want that. So Rio Tinto goes to their mine, they dig up, and they just sell on that. Or they check it. No, they want a 20%. Is it no? If it goes under, they'll be in trouble. But they've dug it up. It's 30%. What do they do? Do they say, well, that's 30%. They're getting a bonus. Great, ship it off to them.
They'll take 10% out.
Sorry.
They'll take 10% out.
Well, they don't take 10% out, but what they do is they mix.
Makes it low,
Mix
right?
and chrome.
Yeah, they I mean, the iron concentration isn't a homogeneous thing, unlike milk. It is not pasteurized even, to the earlier lecture. But they'll have low grade, they have high grade ore, and they mix it together to get exactly the grade that they were selling. Right? So that's what you do with requirements. You deliver what you say. And how do you do it? You ask them to get a baseline, but that's not going to give you a true indication of what exactly you have to build to solve that problem. Right? The second one is actually very important. Right? Derive requirements from existing systems, internal or external. Right? Now, what that means, you want a new system to do this. Hey, show us your existing system. And basically that'll give you a good idea of what features it has, how it does things, to be able to solve that problem. Now that can be true for whether they're already using that system or whether there's such a system out already in the market. You basically go and rip it off, right? Not that you sell them that system, but you see, okay, what are the features? If you're looking at a banking system or a tax account system or whatever system, what do people expect? Right? Now there can be a natural resistance to this and to say, well, we're not going to bother looking at anything, we'll make our own thing. And that's kind of not exactly a good attitude in terms of making yourself work efficiently and also making the system as good as it can be. Right? So for example, I want to create a word processor. Okay? So I'm not going to look at any other word processors. I'm just going to do whatever I think is best, right? That's crazy when you think about it, because you've got Microsoft, right? They spend millions and millions of dollars testing, working out what the features should be, how to make it easy to use, how to make it efficient, effective. You copy what they've got, right? You use their investment to make your product better. A classic example, I guess, as well is if your software product is a game, right? And let's say you want to make a game of a particular genre. Now, let's say you want to make a strategy game, a real-time strategy, or you want to make a first-person game.
But why not Battle Royale?
Sorry?
Why not Battle Royale?
That's popular these days.
Battle Royale.
Battle Royale or whatever. But basically, you don't go out and, let's say you make an RTS. You don't go making your own custom control system, and you basically look at other games of that genre. What do they have? Like, what are the controls people are already accustomed to? And that'll kind of make it so much more suitable for the task. Now there's a danger with that, right? Because the existing products you look at might be crap. Right? And we did a project a few years ago to basically, it was in two parts. It was an educational games project where one part was the actual educational game that students played on their mobile device. But the other part was an analytics backend for the teachers. Right? And the question was, okay, what kind of data should we present to the teachers? And you look at all the publications about similar systems, You look at similar systems and you can see the types of graphs they produce, time spent versus achievement gain, and all kinds of graphs. Efficiency, like how much time versus performance. And we started off prototyping those and showing them to the teachers. And the teachers basically said, yeah, I know Mathematics has that, or no, we shouldn't give product names, but anyway, I know this product has this, but I never look at it. Actually, I don't even know what it means. Right? It turns out for school teachers, really what they want to see is a single screen that encapsulates their whole class, and they'll be able to pick at a glance, this person's struggling, they need help, this person is doing really well, they don't need help. Right? So we took out all those fancy graphs and we basically replaced it with a matrix where each student had a light. The light could be either green or red or orange. And the teacher set the threshold. So if you want to set the threshold at 50%, if you did above 50%, green, otherwise red or orange, somewhere in between. Right? So there is a danger in deriving requirements just from existing systems, because the existing systems might not do it the best way that it can be done. Right? And if you can do it a better way, all right, you probably will have a market advantage. If you do it the same way, you're not at a disadvantage, but you're kind of creating something that's the same as everything else. Which it's a safe option, but not improving. So developing prototypes, I guess that's key. That's how we found out actually that these fancy graphs with all this, it doesn't work. These were maths teachers, by the way, so you kind of expect, okay, they're really hands-on at reading graphs and interpreting. One thing is they're not really, and the other thing is when you've got 30 students in the class, you don't want to go through 30 graphs and try to work out what that means, right? That last point there, joint application design, or JAD, as it's called on this slide, is an interesting way of doing it. Have you guys heard of it? Come on, you said you've like done this in 5 different other units and 10 other different ways. But joint application design is where you actually bring the problem stakeholders, the clients, the people that don't know about software, and you make them part of the design process. Right? And this kind of came about, actually even I think back in the 70s, it came about, and I can't remember the guy's name, but he ended up going to IBM and using it quite successfully. But basically what it is that you have big meetings where you've got the software developers and you've got the clients designing it side by side. Now for that to work, that needs a lot of preparation. Now you can't just take software developers that don't know anything about the problem domain and problem domain experts that don't know anything about software development and put them together. That's not going to result in anything useful.
What's the wrong with doing that?
Sorry?
Sure, that would be useful. I can't see a problem with that.
Well, joint application design actually starts off with, as developers, you do your regular thing where you look into the domain, but you also do that on the other side, and you give the domain experts some training of the process of designing and developing an application. Right? And you guys know, you don't believe it, right? Because you live in the software world, but once you meet some actual clients who aren't all that computer literate, besides using Facebook and things like that, typing an email, you'll realize they kind of have no idea of this logical process of building software. They just think it's a magical box, with magic and mystery, right? And so taking them through, this is how you actually build software. We've got these prototypes, and we've got these increments and these features, and this is what our user interface is, and this is how we work out which elements go on there. And then you get together for this meeting, and the meeting might last several days even. It would be over several days to flesh out a design. And that was shown to be very successful, actually. Now, if you want to Google it, there's not that much more info in the notes. So it's quite successful. And again, from the last lecture, the number one key to having a software project succeed is client involvement, right? And this is the deepest client involvement you can get. Now, what's the disadvantage of this? Scope creep maybe, but that's something you can manage. But the disadvantage is that you got to go through this process. Now you got to take all these problem domain experts away from the job that's making their company money, and suddenly you're teaching them about software development. It's something they might never actually ever have to touch again, right? So basically, it's costly. That's in a way to put it. All right, and this is kind of more towards, okay, what do they want? Well, review the documentation of any existing system they've got. This is actually quite good. I mean, I kind of said look at existing systems, but another way to look at it is don't look at the existing system, look at the documentation. And I think back in 2009 we were doing a software prototype. Basically, we're trying to get do you guys know what a CTG machine is? What is it?
I forgot what it stands for, but it does scans of your body and get a bit of you needed.
That's almost. That's a different. That's a. I can't remember the acronym. Yeah, there's a CAT scan. But CTG, cardiotocography, which is basically a probe that sends out sound, gets it bounced back, and you guys know the Doppler effect from when you didn't do physics. There's the frequency of the sound the frequency changes based on the speed that this thing making the sound is traveling at, and it uses that shift and it amplifies it. So you can use it to listen to your heartbeat. No big deal, you can get that from a pulse. But what it's used for is listening to the fetal heartbeat. So if a woman or a man is pregnant, you can hold this. You can hold this probe and to the baby's heart, and you can hear the heartbeat. Now they've got these machines in hospitals, but of course when you're out in a remote community, you don't have access to such machines. But you do have portable ones. Handheld, you hold it there and you can listen to the heartbeat. And we developed an application that runs on a mobile phone. You take the audio out of this portable unit, you feed it into the headphone, the headset. So, thanks Apple a lot for getting rid of that port. But basically our software processed that sound, worked out how many beats per minute, drew a nice graph like you get on the hospital machine, and send it over the network to an actual server, and the midwife could have a look at the graph and so on. Right? So that was quite successful, but how did we get the requirements of how would the midwives interact with this? Well, we looked at the expensive CDG machine, we got the manual, we said, okay, this is what it needs to do. You ask a midwife, different midwives use different features, they look at it different ways. You look at the manual, this is what the current hospital system does, this is what we're trying to replicate, this is what we did. There you go. And it was a nice success. It was funded by Microsoft Research, and the developed version ran on a Windows mobile phone, believe it or not. And we ported to Android once Android came out. This is kind of before the days of apps being mainstream. So it's a good thing. So what are the characteristics of a good requirement specification? So you do this process, you look at the problem, you come up with this document. How do you tell a good document from a bad document? Right? And it's very important to be able to tell, right? So one thing is you specify what is to be done. What is it going to do, not how it does it. Right? forms a contract, so that's an important thing. That's why it should tell you what to do. It shouldn't really say anything about how it does it, because you want to be flexible, right? And now doing it, what do they care, right? Whether you use C++ or C#, or they don't know about languages. If it's a real proper document that's accurate, it's the basis of deriving tests. Why? Because point number 2, right? It's a contract of what you're delivering. If you want a set of test cases, does this thing meet the requirements? This is what you test to, the specs document. And it documents customer needs before diving into design. So you kind of need this document which says, this is what I'm going to do before you design how you do it. Because if this changes, your design is going to change. Right? So let's go to the IEEE. What do they say are the aspects of a good requirement specification? Right? So it has to be unambiguous. What does that mean?
That's very clear. You can't confuse, it explains itself.
It should only be interpreted one way.
Exactly, yes. So it's not like I read it and I think it's this, and you read it and you think it's that. No, there should only be one way of interpreting it. So it has to be very clear, very precise. We'll see another example, but one example of ambiguity is when it's actually quite characteristic when you go into various areas and each one has its jargon, and one concept may be known by several different terms. Right? And the key is to be consistent, use a single term to refer to the same thing, otherwise people will misinterpret and they'll think, oh, this is something different they're talking about now. It should be complete. That kind of makes sense, right? It's a binding contract, this is what I'm going to deliver, so there shouldn't be this other stuff that you also have to deliver that's not part of this. Right? Verifiable. Right, so if you have a generic statement in the specifications, it's no good, right? Because if you deliver, if you have this software, this final thing, you should be able to check off, does it meet this item in the specs? So a good example is a requirement, it should be user-friendly. How do you interpret that? How do you test that?
Get users to actually try it.
Okay, so that's, and then what? Was it friendly? And who's the user? Like, could have 10 different users. Can you just pick one? And if they can use it, then it's fine. Get all 10, right?
Yeah.
What if it's got 100 users? What if it's got 1,000 users? What if it's got 1 million users?
Take a stand.
Well, the best way to solve that is not to have a requirement saying it's going to be user-friendly, because that's a nothing requirement. And really, if you give someone enough training, anything can be user-friendly. Now, this could be a console that you type stuff into. Now, if you give the user 100 hours of training, it's user-friendly. Yeah? So really, rather than having something wishy-washy like that, specify what you mean. So all the functions should be controllable from a menu. No, you shouldn't take any more than 2 clicks to get into any other whatever, right? What exactly is going to make it user-friendly?
Could you cite, like, for example, for that example, could you cite user accessibility standards?
Yeah.
Yeah.
I mean, that's part of defining a user, right? So, okay, you know, it's most people.
I think there are like legal user accessibility standards.
That's right, for some types of software, that's right, yeah. And so, for example, you might be good at using a keyboard, but someone with no arms isn't that great, right? consistent. So I guess that's also partly the different terms meaning the same thing. One requirement saying something and some other requirement contradicting it. That's what you need to avoid. They should be traceable. So each point in the specs should relate back to a problem that you're trying to solve. And believe it or not, our good requirement specs is a usable document where you can take something from that and implement it. And the typical breakup of a requirement specs is an introduction that defines briefly what you're, or in detail even, what you're trying to make, and then have a list of functional requirements. Functional, what does that mean? I think this is something you all should know. What does functional requirement mean? Well, feel free to read it out from the slides. Okay.
What
What's a functional requirement?
What's the system
No, it's not what the system's going to do. It's what the system will do. That's what it says on the slide. It's the same thing. No? What's a non-functional requirement? It's what the system won't do, right? No. It's kind of more into how it does it, in terms of how fast it might do it. Right? Whether it'll fail every so often.
security?
What things will it need to meet? So, okay, it's great. You're managing. You got this software that's managing these bank accounts, but hey, you need to protect the user's passwords. You need to protect your database. Every time someone touches anything, there has to be an audit log trail that's written down, and so on. Right? So they're non-functional, but the system could do these things without meeting those, but those are actually very important as well. And I mean, you're going to get practice with this in the workshop, so don't worry too much, and even more practice in your assignment. But for each function requirement, this is how it's kind of written up, where you have a purpose, okay, this functionality that you're adding that solves part of this problem. What does it do? Right? What is it? In other words, what's the input that it needs to do that? And what output does it produce? So basically, what goes in, what comes out, and what does it do? Okay. If you have that, it's very easy to test. Now you can come up with a test case based on what the inputs are expected. Do you get the right output? And if you're doing black box testing, you don't care about the processing. If you're doing white box testing, you go through and does it go through, and each path actually results in a successful test. Right? We covered it later. And some examples of non-functional requirements. Now, functional ones are kind of easy. This should fly the plane without randomly crashing it every now and again. What's the bet that this 737 MAX, what's the bet that it's a software problem? It's kind of a pretty, or it could be coincidence as well. But no one's waiting to see whether it is. It's saying don't fly those things anymore. So performance, notice. And another example of a bad requirement is it has to run as fast as possible. Yeah, if I'm making it as fast as possible, it means you've got to wait a couple of days. It's just me. I couldn't make it any faster. Right? Or a requirement could be it has to run in real time. What is that? What's real time? Like for some systems, if you have to wait a second, that's okay. That's considered real time. In other systems, if your autonomous vehicle detects something in front and you're going at 100 kilometers per hour, maybe 1 second isn't an ideal response time, right? So definition of things like real-time changes. So be unambiguous, be concrete, right? Response time with 10 simultaneous users using a database size of 1 gigabyte, there should be a 20 millisecond response time. Availability, 99.99%. Very good. How do you test that? Secret is you don't. You just charge them for it, and if it fails, you say, oops, sorry, but we followed best practice as outlined in these documents, and we couldn't foresee this. When you deliver software, okay, like if it's an online thing, you can hire people and they can get it up a lot of the time. But if for some reason the thing crashes, you somehow didn't pick it up in testing, what do? You give the money back? I don't think so, right? And security, what does that mean? Security is basically a psychological concept, and you kind of enforce it by making things look like that your data isn't going to be touched by someone else, right? And as we know in practice, through if you use LinkedIn or Facebook or Sony or pretty much every company has had a data breach, right? It doesn't matter how many millions they spend on security. And, it's a big company, lots of people. Data gets out. Right? So it's great to have these non-functional requirements. Another word for non-functional kind of means that very hard to test. I mean, performance is very easy to test. It's if you're running it on a machine and suddenly it decides to defragment the hard disk, what do you do? And we had this. Where was it? This properties of good requirements. So what are properties of bad requirement specs? Basically the opposite of these, right? So we're not going to go through and say potential problems is the opposite of those. Okay, great. Kind of know that. I don't know. Should we go through the different ways to get requirements? Now this is it, by the way. This thing I mentioned earlier, that's like a mathematical way of specifying requirements. So even a very simple requirement that this function should add a score, based on what a player gets onto their existing score, it looks like this. Right. And the idea is that you can write something that'll somehow run it and prove it. Is it giving you a headache? Is this what you want to look at when you see a requirements document? Not really, right? Is this what you want to look at when you see a requirements document? So here's an example of a PDL, a program definition language. Now the good point is, with this and with specs in Z, is that they're not written in English language, and basically any kind of spoken written language that people use is by its nature ambiguous. There's redundancies, there's different ways to interpret the same thing. And that's really why PDLs and Z were invented, to kind of overcome that. But the problem with a lot of those is it kind of looks like you're already making the solution, right? And someone who doesn't know about programming and just wants to see, what am I going to get? Would you show this to a customer? You've got to be crazy, right? Would you show this to a customer? They'll tell you where to go, right? They say, well, I'm going to get my backing software from someone else if this is what you're going to deliver. Now, if this is your specs, imagine how usable your actual system will be. Right? So a good way is a prototype. Right? Show them this is how it's going to work. This is what it's going to do. And kind of a middle ground between a text document and a working prototype that they can use is a UML use case diagram, right? And the documentation of the associated use cases. So let's have a look at an example of when we write requirements just using English, what the problems could be, right? So these are the requirements for a system to monitor a chemical reaction in a large plant. This is one of the most important things in this lecture that you actually should be paying attention to, right? Because this is looking at requirements and critiquing, right? And when you're a software developer, if some manager tries to write a set of requirements, you're going to have to carry the can and implement. You need to make sure you can do this, right? All right. So the Perf Chemical Company System Requirements 1, version 1. The system should have an easy-to-use interface. Should we keep that there? No. Get rid of it. Right? It's, another name for it is a platitude. That's what it says here in my lecture notes. What's a platitude?
It's something to appease the person that you're selling to.
Yeah, without actually meaning anything. Right? It's like when I come into the lecture every week and I say, oh, today we're going to learn about something very, very interesting. It may be true, it might not be true. It's depending on who you are. It doesn't mean anything. Okay, now we get to something concrete. So the purpose of the system is to monitor and report on the operation state of the reaction chambers of the Perf Chemical Company. It should be, right? So there's one on the Perf Chemical Company. So maybe they're on the roof. I don't know. No? So that's okay. Now, one problem with this, it's trying to say two things in one. So it's monitor and report. It's not so bad, right? As long as there's some other parts of the document that expand on what that means, and there are, right? Now, one thing that's missing from this is how many reaction chambers? Is there just 2? Or is there 5? Or is it a dynamic number? Where you could have n and this doesn't tell us, right? Okay, we go on. Right? So requirement number 2 was that it should be monitoring and reporting, and these explain what those mean. So monitoring means this, reporting means that. So it says monitoring consists of checking that the temperature and pressure of the reaction vessels does not exceed specified limits. That's a good question. What are those limits? Is there just one limit? Or is there an upper limit and a lower limit? This doesn't tell us. So we're looking at temperature and pressure of the reaction vessels. Does that mean all of them, like an average pressure and temperature of all of them? Or in each specific one? Is that what we're looking for? Now, if you were writing the software based on this, you wouldn't know, right? You'd have to ask more questions. Where really, this should really encapsulate what the solution will be, without any other questions. So that's what monitoring means, apparently. There's some ambiguity in there. There's some things we're not sure about. What does reporting mean? So reporting means allowing an operator to interrogate a file of temperature and pressure readings stored over the past 72 hours. Okay, so that's okay. So, but I mean, even in that, like, again, is it like an average temperature and pressure for the whole set of reaction chambers, or is it one by one, the individual ones? Yeah.
What type of file are we supposed to output to an Excel file? Is that what they're interrogating?
What type of ID?
This is type of-
Yeah, that's kind of getting too low level though. When you start, you know, and does it have the lowest significant byte first or last? Or is a, no. There's a, so some kind of file. How it's interrogated? Okay, that could be
What does it mean by
expanded. Well, so there's one question. Interrogate? No, if they catch you at the airport and they interrogate you, what does that mean?
What does that mean?
Right. So are you supposed to take this file and do a digital examination?
We then check for forensic evidence.
You guys know what a digital examination is, right? It's got nothing to do with computers.
What is it?
Well, what's a digit?
You get there when you try and join the army.
Yeah. Go. Apparently, the thing that people never do in response to one, but is the ultimate way to get control back, is to go back. But apparently, they always go forward. You know? I mean, in our school, we've got various disciplines, and we've got people in the intelligence discipline, and so this guy was telling me that he used to do them apparently, and everyone just goes forwards. Apparently, so if you get caught, go backwards, and it'll freak them out. So exactly, what does it mean? Does it mean we can put more? No, we detect an error there, we can change it. Is it something that we should be able to pull up on a GUI and graphically interrogate, or we do have to open the file in a hexadecimal editor and see what it is? It doesn't tell us. I mean, past 72 hours, okay, seems to be kind of arbitrary. But, okay, let's leave that. So this next one, number 5 is all right. So it gives you some details. So readings of temperature and pressure, along with the reactor number and the timestamp, are transmitted via serial line to an IBM PC with 128 megabytes of memory and a 30 gigabyte hard disk space.
Absolutely.
Okay. So that's okay, but you're mixing functionality with how it's done, with non-functional requirements, and you shouldn't do that. Huh? So basically, you need to say that for each reactor, the data consists of temperature, pressure. You should really specify what units they're in. Right? And what else? We got a reactor number and a timestamp. Yeah? And then you can go into all kinds of other requirements in terms of what does that timestamp mean, right? Does it have to have the date and the time, and does it have to have the year, or does it have to? Is it we're storing? Are we actually storing them? Because for reporting, you can interrogate the last 72 hours. But what happens to the data after that? There's not. Do you still keep it, or does it have to be wiped for some reason? We don't know. Right? The system must be programmed in C++. And must not cost more than $10,000. It's non-functional, right? It's not what the system does. So here we go, number 7. On receiving a temperature or pressure reading that is outside the safety limits, so now we've got limits, which means lower than or greater than, the system should close down the relevant VAT and send the name of the VAT to the operator's PC. What's wrong with this?
What are the limits?
So that's one. Okay, we know about that already. What's the big problem with this requirement?
Operator. Who's the operator?
Well, it's a small thing. What's the huge thing here?
It's not trying to rectify it, it's just shutting it down, but that's not necessarily going to stop it.
Shutting down the reactor.
But like,
Hey, hang
it's
on.
not.
Is that part of monitoring or is that part of reporting?
That's monitoring.
The system was supposed to monitor and report. This is now trying to control the reactors.
Yeah.
It's not just getting data offered and letting someone view a report. Now you're controlling the chemical reaction suddenly. That's not what we signed up for. So this now opens up a whole can of worms, saying, hang on, this isn't what we said in was it requirement 2 or 3? This isn't what we said the thing would do. Right? And I mean, is it just one operator, or is this operator's PC the same PC that was on the previous slide that was logging the data? How many PCs do we need? Does it need to be the same? We don't know. Right? What's a VAT?
What is it?
Vessels in the past.
If you go on the previous slide, we had a reactor. On the slide before, we had reaction vessel. Previous slide,
Inconsistent.
reaction chambers.
Inconsistent.
Inconsistency, that's right.
And how do you close it down?
Just by there's a power button there.
Does it mean close it?
Well, exactly, because I mean, it went into all kinds of details about where was
Closing
it?
down could be the same as turning it off. That some people consider that closing it down. Closing down could be literally closing it down.
Well, here it says when you're logging data from it, it tells you you've got a serial line. Okay, there's a bit of wire there. It doesn't tell you which protocol to use for a start, right? But it tells you in detail. You get this thing with a timestamp and blah blah blah. But how do you shut down the VAT? Do you send something over the same line to something, or it doesn't say yes?
It also, like this here is talking about recording the serial number of, well, the previous slide was talking about the serial number, now it's saying send the name of the VAT, so there's ambiguity there.
That's
Is
right.
there a
No?
separate
Before we
name?
had numbers, now we've got a name.
Yeah.
How do we know what the name of that would be?
So, well, I mean, in all of these, what do you do? Is you say, well, it's version 1. We need to ask more questions about this and expand. Right? So basically, you wouldn't accept these as a requirement specification. You'll say, hang on, this isn't complete. We don't know. We need to find more answers. We can't sign off on this. Yeah. The system response should be the maximum possible achievable.
What does that even mean?
Exactly. What response to what? Does that mean shutting down really fast, or generally it should be responsive, or?
What type of response?
No. Doesn't say.
I just means it has to be as long as possible.
We can't achieve it.
Yeah? Maximum means the most, right?
Right. Yeah. What do they mean by maximum? Do they mean the highest or lowest? Depending on what sort of they're talking about. Response could be a maximum or
Yeah.
or it could be a highest or a lowest.
Yeah, you want to maximize the amount of time before the thing blows up, right?
Do you want to maximize how long it will take until you get a response? Do you want to minimize how long it
Well,
will take a response?
I mean, and what's response mean?
Exactly. Like I said, until you get one, which
It's all subjective.
So these requirements are rubbish. What are you guys doing bringing these into me to critique? What were you thinking?
what does it mean by achievable?
Sorry?
What does it mean by achievable?
Exactly, I mean, you look at the class, the grade achievable varies, right? It's basically how much work are you prepared to put in? And yeah, if you don't put any work into a unit, this is the maximum achievable. This is if you study every day and you live and breathe requirements analysis, maybe do 1% better, Actually, where was I? Should we keep going through all of these?
Why not?
Yeah, let's do it, right? Just so we have it there. Just so you can't tell me that you didn't teach us this, Martin. The operator should be able to display on his/her PC, and why just limit it to his and hers, right? It seems not too PC. The average temperature or pressure reading from a specified sensor for any number of hours.
Sensor now.
So hang on, I thought we said we're meant to let them interrogate this file, and that was the reporting, and now this is something else? This is different. And any number of hours,
What type of sensor?
but before we said 72 hours is the maximum.
And any number of hours in and of itself is ambiguous, because does it mean for a specified number of hours, or does it mean for the maximum runtime?
I mean, when you talk about an average, why would that even be useful? What's the average temperature over the last 25 years of this reactor chamber? Oh, it's this, okay.
What does it mean by specified sensor? Does it mean a sensor you've already specified, that sensor will always be the one, or the one that's actually related to the average temperature or pressure reading? Like, it doesn't.
You've also specified sensor is that specified sensor on the vat as, you know, like, is that across all vats, or is it a single vat? You know, each vat only has a sensor, but are you looking at across all vats? That one sensor across all
That's
vats?
right. And what does the mean? Now, it's used quite a lot in the requirement specifications. And of. No, what does it mean? I'm just joking now. But you can go overboard. but these are, no, there's a lot of holes in here, right? And names of reactors currently functioning, that they should be displayed.
What does it mean by function?
I guess the ones that haven't been shut down, I guess. And what about the ones that have been shut down? They just disappear and you can't see them
When
anymore?
you shut it down, the reaction might still be going, it's just not outputting anything, so the reaction might still be functioning, but the reactor itself isn't functioning, it's not outputting anything.
Is it going to be like that Chernobyl place, right? Oh, we're going to shut it down, so it sends the packet of information saying shut it down, it disappears from the screen, so you don't see it anymore. It's all good, right?
It's not.
What's this multicolored firework?
See, I dodged a bullet there actually, because that blew up in '89, I think. When did Chernobyl happen? Who can do it? Somewhere around there. And I got out of Europe in '85.
I remember.
And I was already here. I was in primary school in I think it was Boulder Primary School. Has anyone been to that school?
No, I don't think Boulder.
Well, in Kalgoorlie, Boulder now. Yeah. So I dodged the radiation bullet there. No, because that radioactive cloud went all over Europe, basically.
I
It's,
remember the news following it.
So how should we improve it? Basically, we should ask and resolve ambiguities. Here's one example. The system shall be user-friendly and fast. Well, if you load it up and it crashes straight away, then
That's fast. That's fast.
it's pretty fast, right?
But it's not user friendly.
I had a... Do we have time for another story?
Yeah.
I had a user-unfriendly experience. And I need to talk to someone about it. Can I?
Don't worry, everything said here is confidential.
Yeah, well, I didn't want to...
Won't leave this room.
I didn't want to use the issues counselling service because I know the Vice Chancellor listens in on those. But I'm working on it's an academic paper together with various colleagues, and They send me a version. You guys know about Microsoft Word? You know about the track changes mode? Where you can turn it on and it tracks what you type, so it's much easier to work with. So that's what I put. It had some comments, and I added my changes to it, and I reshuffled it a bit, and I saved it, and I sent them an email, and then I attached it. And I said, well, here's my changes. I've done this and that, and then this is yesterday, and then I went for a meeting in Mount Lawley. And in Mount Lawley, I get a message, I know, can you resend the document? I can't open it. And then I got another email saying pretty much the same thing. And I looked at my sent email, I opened up the attachment. Where did I even put it? And yeah, no, the attachment something was wrong with it, so I'll go to the original file and I'll resend it. That didn't open either. It'll be under research, 2019, Journal of School Health. Paper for Poo Game, don't worry about that, is with nutrition education experts, and basically we used applied IT project students, by the way, but they made a game where you ingest different types of food and it shows you the effect on your digestive system from the input to the output, right? And I opened it, Word loaded up. I think this must be the fixed version. Back up. This is what I got. We're sorry, we can't open paper for Poo Game version 8 because we found a problem with its contents. Go to the details. XML parsing error. This line 2, column 93,257. So you guys know Microsoft Word is a huge user-friendly document. This is not, right? I fixed it. This is the procedure. You rename it .zip.
And then you unzip it.
You don't have to. Because basically a docx file is actually a whole collection of documents zipped up and given a different extension. Right? So there it is. And the error message told me where the problem was. And I think, does it have images? This is another tip. If you're trying to get the images out of a Word document, they're in a folder here. Right. If you go to, there you go, media. So there's an image from the Poo Game, no danger, constipation. See, when you're working at a uni, it's not all just really fun stuff about requirements and stuff like that. But the error was in document.xml. And if you open it up in Notepad, this is what it looks like. It kind of trails off at the end. Close that down. And the trick is you take it out of there, out of the zip file. And there I've got, you open it up in Notepad++. It's only got 2 lines. It's got all the content of the document. I think this is the fixed version. But basically there were a couple of lines where it just had a null character. Somehow it had been corrupted. So I manually deleted those from the XML file.
It wasn't Blackboard.
It hadn't gone through Blackboard actually. So I manually deleted those, put this XML file back into the zip file, and I could open it, but it had, parts of it had gone to crap. Basically, I had weird stuff. Even now, I opened the fixed document, and it now it doesn't. But before it was giving errors like, there's this font which is taking up too much memory. It's scrambled some of the text. So this is I kind of had to go at fixing it up before sending it on. But Word, for all its user friendliness and the millions and millions of dollars spent on making it good, this is actually wasn't that great, right? And because I know how to look into a Word file and edit an XML document. If you gave this to someone in nutrition science or nursing researchers, they wouldn't know what to do, right? They'd retype the thing from scratch and lose huge amounts of time, right? And it kind of made me realize that ages ago, before you had autosave, before you had track changes, you just kept all these different versions of your document. You could go to the earliest version. Now you've got these things to help you. Now, it saves your changes. It tracks the changes. But if that one file gets corrupted, hey, be careful, right? And I was talking about to a colleague as well, and he said, but it's even worse now, right? Because right now you still can change it, and you're sending it by email. So there are multiple versions, multiple backups kept that way. But now everything's going to the cloud, right? Where you have one version of the document for everybody. Yeah. If that gets corrupted, hey, it's not that good, right?
Yeah, that's what happened to me.
Look, I shouldn't have told you guys this, because now I know what the excuses will be when the assignment due date comes, right? So how can we fix this? The system shall be user-friendly and fast. Well, expand on it and make it concrete, right? The system's function shall be activated and terminated by menu selections. Functions shall be initiated within 500 microseconds after their selection. That's something that's testable, right? You test it, you time it, it takes longer than that, it doesn't meet the specs. The system shall be user-friendly and fast. Yeah, for me it was great, and it was fast enough. I mean, back to the games industry, the classic mistake people make is the developers think that they're the end user and the gameplay is fine for them, they can get through it, so they ship it out, and it's way too hard for anyone else. Because they've been playing it every day as they're developing and tweaking. It's unplayable by anybody else. All right, there we go. So this is something that's interesting, right? Because usually you get some type of conflict. And the example is kind of number of chips using it. Basically, you're building a spacecraft, and you want to make it as light as possible, and as kind of minimize the power consumption as low as possible, right? And basically, it's saying, well, the lower the power consumption, the bigger the weight. You guys know about use cases, so we're going to just skip over this, right? In use cases, you have actors, you've got the system boundary, and you've got the use cases, right? We talked about it last week even. You know what actors are. This is a use case diagram. So what's this? This the symbol for? Actor. Yeah. And last week I said, well, if this acts as another system, how would it usually be implemented in that other system? Yes, that's right, as a class, that's what I said. It's kind of a class that you're talking to, that's sending messages to you, or you're sending messages to, but it's outside the system, that's why it's called an actor. What's that the symbol for, that arrow?
Generalization.
Yeah, what's another name for that? Generalization's kind
same thing.
Inheritance is usually the word for it, right? So you can see they are class. Now you've got the concept of inheritance in classes. Who inherits from who? Which is the parent, which is the child? Visitor is the parent, subscribes the child. So is it true that the visitor can do whatever the subscriber can do plus extra stuff?
Subscribe.
The other way around. Very good. What's another name for that relationship? It ends in "a", and it starts with either "has" or "is". No, "is a", right? So you can say a subscriber is a visitor. That's inheritance. "Has a", on the other hand, is aggregation. You could say a subscriber has a visitor, and has this other style. It's actually two ways of implementing the same thing, but we're not going to get into that, right? You can reuse functionality using either inheritance or aggregation. You'll learn that later on. The system boundary and the use cases, right? So what can a visitor do? A visitor can browse the site. A visitor can contact the editor, can subscribe. What's the characteristic of a good use case? Name. Slap yourself. Not verb noun analysis is the is the technique of coming up with with classes and methods, sure. But the name of a use case should be a strong verb. What's a verb? Let's have an English refresher.
Doing.
It's right, a verb is a doing word. What's a use case? A way of doing something with the system. So browse the site. If you had a use case, the site, it's not a use case, that's not a way of using something. It is a website, so you don't really need the site. You browse. Subscribe. Contact editor. There's nouns in there, but that's kind of the key is the verb. And there's functionality that might be common to some use cases, so it's okay not to take it out. You can because you don't see it in the diagram, but then when you do elaborations, you have to have it in there, right? So sometimes it's better. So something like authenticate subscriber, use the includes relationship. And the way you read this, you've got this arrow, access full journal, includes authenticate subscriber.
Oh.
Any questions?
Yeah, which way does the extend arrow go?
It's as was presented on the slides.
That's wrong.
Okay. That was just a test, by the way, so I'm glad everyone picked it up.